We're going to start the day by talking about the value of reactive and precisely why we want to do that, or why should you care at all. So to do that, with me I have Violeta. Hey.
Hello. My name is Violeta Georgieva. And the last 2 years I was working basically on Reactor Neti together with Stephane.
What she didn't say is she's also a main core contributor of Tomcat, which is funny because she knows Tomcat very well, and she's also very much involved in Nedi project, which is another runtime. So it's interesting to have this experience. And I am Stephane Maldini. I lead the Project Reactor and everything reactive for Pivotal. So I worked on a bunch of reactive projects for the company. And both of us, we work on Nedi, Reactor Nedi, and Reactor and Spring WebFlux, Spring Cloud Gateway, and all things using Reactor Nedi directly. So that's where we come from. Right. So I'm going to do a quick reminder of what we think is reactive programming in a nutshell. At least the perception usually people have from reactive programming in general. So the first keyword people use when they think about reactive programming is hyper-efficient, hyper-scale as well. They think, and it is partly true, that if you use non-blocking or reactive programming, you can create super efficient applications. Also, when we think about reactive programming, we tend to associate it with non-blocking programming and concurrency. So that's also true, partly at least. We make use, at least in Project Reactor, we make use of non-blocking programming. We also associate, it's very smooth, it's very loose, but we also have a relationship between Reactor and functional programming. So if you heard about functional programming, you know it's different, obviously, from imperative programming. And we actually dive into that in a moment. And also, when we think about reactive programming, we think about these properties. If you've heard about the Reactive Manifesto, at the time already a few years back, they were advocating for reactive programming, and they mentioned this is something that helps you making resilient applications. And that's true as well for reactive programming. It really helps you making application more resilient. You can also interrupt in reactive programming, which means if the task is taking too long, a reactive task is taking too long, you can cancel it. You can do it in multiple fashions. We'll see that. And also, another quality of reactive programming, at least with the specification we implement, namely reactive streams, we can use synchronous or asynchronous processing. That means we don't have to use an extra thread to do reactive programming, and we'll see that in a moment as well. So that's what we know about reactive programming, and usually when people think about that, they match it with very big default, like. When we create hyper-efficient application, in all mind, what we tend to also think about is it is actually adding a lot of overhead for low-volume application. Same for what we think is non-blocking. It's very difficult to find exactly what is non-blocking. We'll see what I mean by that. So, for instance, if I get into the detail of functional programming, we know that in imperative programming, things look as you expect, like that. A for loop is, all of you probably know how to do a for loop already. We understand this kind of code. But when you switch to functional programming, the code becomes more subtly different, I guess. You differentiate the intent in multiple lines. You don't nest the intent. So that's a mindset change, and that's one of the main difficulties when I visit customers and the community around the world. People keep telling me, like, this mindset change is preventing us from switching from what we're doing today to reactive programming. The other difficulty people have in general is when we switch from synchronous to asynchronous code, we use internally in Reactor and Spring, we use some interesting construct, and we make use of a pattern which we call work stealing, and that makes the stack trace very interesting to read. And unless this kind of people and you actually know just straight out of the box, I can actually translate this stack trace into what happens. It is impeding in your reactive transition. Like, it makes you a bit afraid of adopting reactive programming. You don't want to have this kind of stack trace in your code, do you? What is non-blocking as well is an interesting question, because usually if you come from Spring, you know this kind of construct. Using REST template to access a backend REST endpoint. Everyone knows this kind of construct, at least everyone using Spring today. The problem is in reactive programming is if you do that inside what we call an operation or a callback in a reactive pipeline, so for instance, the operation do on success, accept a callback, and you use this REST template exchange code inside. What you don't know is when you start with reactive programming, this is forbidden. You cannot do that. If you do that, you will break your reactive application. You really cannot do that. It's a big problem. So that's a difficulty, because usually when you start with reactive programming, you want to integrate existing libraries, and you don't know what other teams in your company have done, if they have done blocking or non-blocking code. It makes integration with existing stuff quite hard. So the other thing I briefly talked about the fact we can interrupt reactive pipelines when I introduced reactive programming. In blocking style or in imperative programming, it's pretty easy to read what happens at the end of a function. Basically, when you read the signature and you call a method, when it returns, it has a data or it has nothing if it's a void return type. Or if there is an exception, you will have an exception raised, and you can try catch the exception. So you know already this kind of behavior. When you switch to reactive programming, we'll transform all of this behavior into signals. That means we don't throw exception, which makes some interesting aspect. We'll see about that. But it also means we have different way of exiting a pipeline, a reactive pipeline. So we have cancel, meaning we can interrupt a task from a consumer perspective. We have incomplete, which means a producer of a result has nothing more to produce. And error is actually becoming a signal. It's not an exception we raised now. And the fact is we have a matrix of different possibilities. If you combine a reactive pipeline can produce no data, can produce a partial amount of data, or can produce every data and then complete, and then error, or can be cancelled. So that's quite more complex compared to blocking style, where you just have a method, you call it, and it returns something or not. So the last thing will be, I mentioned it as well, the overhead. Reactive programming use projects like Project Reactor or RxJava, or even other alternative libraries, including AkaStreams, etc. Doing a reactive programming doesn't come for free. It's actually slower than doing imperative programming. So why is that? Well, we do have to allocate more objects. So when you create a flux, it's an allocation. When you create a mono, it's an allocation. That's the kind of object we create in reactive programming, at least with Reactor. So there are more allocations. And then sometimes, because we do handle asynchronous result, we can merge or compose asynchronous result, like you do a remote web client, the new REST template call. You want to wait for this result in a reactive fashion, we will have to use a queue internally. So that doesn't come for free. A queue can be rather expensive on the JVM. The fact that instead of returning data directly, we just use signal, that means we pass using callbacks on next, on error, on complete. These are what we call signals. Instead of just returning, at the end of a method, the data or nothing, is also an overhead. And then you have also all sort of stuff like volatile. We have to use volatile sometimes in our operation because we have two threads competing for a state, for instance, or we have to use more stack size. And you've seen that in the previous slide because we have a lot of recursion happening, so the stack size is kind of different from imperative programming. So that's not a great picture so far from what you can see. Reactive programming has certainly some of these issues. And especially when I talk to customers, I ask, what are your priorities? And the first thing customers tell me, and that's true, I guess, for everyone else, is they are interested in dev productivity, in developer productivity. They want to create features faster than the competition, which makes sense. They want to beat the competition. So that's number one priority, and that's why Spring Boot is probably very successful. And then the second priority in general is, what about day-to operations? We want to make sure application can be observed, can be managed and monitored, etc., etc. So that's a very important priority, to control the cost of running your application. Customer, will tell me that all the time. And then a bunch of specific line of business priorities. And then running cost and efficiency, which nowadays is slightly coming back as a priority, but for a long time it wasn't. It was like more, and people used to have an infinite budget for running applications, and they were throwing money to Amazon or whoever, and that's fine. We can use very inefficient application as long as they are observable and we made them in a very quick way. It's pretty interesting. But usually the running cost efficiency argument is what we associate reactive programming with, which is, again, largely true, but it has to be an important thing like a very important difference with normal applications to make sure that it's worth investing into that. So at this stage, we want to get in reactive programming, but we can be a bit scared about all of these concerns I've just elaborated on, and we try to give reasons to use this stuff in the rest of this presentation. And the first argument we're going to discuss is performances. And believe me, we spend a lot of time benchmarking stuff, comparing what we're doing with ourselves, between Spring MVC and Spring WebFlux, for instance, comparing with the competition as well to see where we are in the spectrum of the frameworks around. We usually, the Spring team doesn't usually share benchmarks because we're not running this kind of marketing, I'd say, for multiple reasons, but we like internally to make sure that we don't have a lot of overhead. We compare well to the competition as well. So to do that, I'll leave Violeta guide through the benchmark she's been working a lot on, and yep.
Okay, before talking about performance, we will speak a little bit more about what kind of processing we have, because you will have a better view later on when we speak for the use cases and the performance results. And let's start now with the synchronous processing. This is the very basic processing. There we have one thread per request. And what happens, and actually we will go first for the remote calls because they are really interesting. What we have first, when the request comes to the server, we acquire a thread from the server's thread pool. In that thread, we read the request, process the data, and write the response. And what happens when we want to do a remote call? In the processing phase, we block this thread and wait for the remote system to return a response. And that thread does nothing. And at some point of time, because we continue receiving requests, at some point of time, without knowing the processing latency on the remote system, without knowing the network latency, our server thread pool will be filled, and we will not be able to return any more responses. And we will start declining the incoming requests. What happens when we have a mixed traffic, which means we have different remote clients that experience different network latency? Again, when the request comes on the server, in the server thread, we do everything. And once we are ready to return the response, if our client is a slow client, we will block that thread and wait this client to consume the whole response. Again, at some point of time, we will fill that pool, and again, we will not be able to respond anymore to the incoming requests. What will happen if we decide to do asynchronous processing? What will change? When the request comes to the server, we can offload the server thread, and we can do the actual processing in another thread from external thread pool, for example. Again, when you want to call a remote system, you will block that thread, we will continue receive requests, and now what we will have, first we will fill this external thread pool, then because we will not be able to offload the server thread pool anymore, we will fill the server thread pool, and again we will not be able to respond to the incoming requests. Why this is better than the previous processing? Because with this offloading of the server thread, we will be able to serve more requests than before. What happens with the slow clients? We will do the processing in another thread. But once we are ready with the response, we have to return again to the server thread and write the response to the client, which means, again, we block the server thread, and again, we are in the previous situation. Non-blocking and event loops. What we have with non-blocking and event loops is actually the possibility to use a few threads, and in the same time to scale when we have a high load of connections. Here we do not have any more thread per request. Typically we have one IO selector. This IO selector will dispatch the work to the worker threads, and there we will process the request, date, and write the response in a non-blocking manner. Which means then when we want to do a remote call, we will not block the thread. Once the remote system is able to send the response, we will acquire a worker thread and receive that response. When we have slow clients, we will not block the thread. Once the client is ready to receive the response, we will acquire a worker thread and send that response. And something that is really, really important here when we are non-blocking is to not block our threads. Because as I said, we work with a few threads. And if you block them, soon you will not be able to respond to the incoming requests. And here is one example. If with asynchronous processing, we have typically 200 threads, if you block them, you will be able at least to serve 200 requests, right? While with non-blocking, the number of the threads is actually equal to the number of the cores. And let's say we have 4 threads. If you start blocking these threads, you will be able actually to serve only 4 requests. So, without continuing with the use cases, what is reactive programming? Reactive programming is the ability to react on a change. As I show in a minute, this is a network component reacting on an IO events, for example, or, for example, UI component reacting on mouse events, etc. So we can say that non-blocking actually is reactive because we do not block anymore. We wait for notifications that data is available, or some operations over this data is completed, etc. But that's not enough, because with non-blocking, you can receive a lot of events or data. You need a mechanism to say, stop, I cannot handle this data anymore. And this mechanism is actually back pressure. And why it's important? Because if you have a fast producer, for example, and slow consumer, if you do not have a back pressure, the producer will very easily overwhelm the consumer. And now what we have with Spring Web MVC, we have synchronous processing, we have asynchronous processing, and also we support the reactive types Flux and Mono. And this support is based on the asynchronous processing, but this is still blocking. What we have with WebFlux, we are fully non-blocking. And now, maybe you are thinking now, okay, I will switch my web MVC application to WebFlux. Actually, you have to think very carefully on what are your use cases, because there are really use cases where you can gain the best of the reactive. But for example, if your application does not expect high load or does not have remote calls, then you might not need to switch to WebFlux. So the first use case, as I said, is when you expect high load. With non-blocking, your application will be able to scale this high load. When you have remote calls to databases, when you have non-blocking drivers for these databases, then you will be able to handle the latency, processing latency on the databases, the network latency between the systems. The same applies to remote calls to microservices. Streaming is a really interesting use case. If you are not blocking, you have to block the thread while waiting for events or data, while with non-blocking, you do not need to do that anymore. Mobile applications and backends, there we have high load, we have a lot of interactions between the applications and the backends. For example, you have a lot of notifications pushed to the mobile applications. And also with mobile, we have a variety of mixed remote clients. And now let's talk about performance. Performance is a top topic these days. But what we want to highlight here is that we do not want to speak only for throughput, but also for how we utilize the resources, like threads, memory, CPU. And one thing that I want to mention here is when you test your application, do not test your application always in a good environment, but test it with a variety of remote clients, with variety of remote systems where you can experience different network latency or processing latency. And thus you will see how actually your application will behave in reality. That's my load scenario. I have 4K users, which in my case means 4K real connections. The scenario has 15 minutes ramp-up time, then 5 minutes run. I use 2 VMs. The first VM contains the client that will produce the load. The second VM, the application that we will test. Also, I have 2 types of applications. The first application uses Spring Web MVC, the second one Spring WebFlux, and I use the default configurations there, which means Web MVC runs with Tomcat with 200 threads and WebFlux with Reactor Native with 4 threads in my case. And the first scenario that we have is the typical hello world. We love it a lot. So, this is how my controller looks like. This is the WebFlux FN. You can see we are a bit descriptive there. We specify the status code, the content type, then what we want to return a string. While with WebMVC, we just specify the mapping and what we want to return. Here we do not need any asynchronous processing because we just receive the request and return one string, and because of that we use MVC synchronous. And if you want to use WebFlux annotation-based programming model, actually the controller looks exactly the same as WebMVC because, as I mentioned already, we support the reactive types in WebMVC. And what we have as a resource consumption, you can clearly see that in WebFlux scenario, we have less threads. while in the MVC scenario we utilize all 200 threads from Tomcat pool. What we have as memory in the WebFlux scenario, we utilize more young generation, while in the MVC scenario we utilize more old generation. And when we speak about metrics, what is the numbers that we can surface requests? You can see that when we are in the WebFlux scenario, we are able to serve 2 times more requests as numbers. And as a response, WebMVC is 2 times slower than our WebFlux application.
Let me ask you a quick question with this graph. Does anyone know why it does matter to use less of all generation? No? Okay, so the more old generation you're going to use, the more likely you will use a bigger garbage collection, a slower garbage collection. And what happens when you use a garbage collection that tries to clean the old generation? Well, it takes a lot of time. It will pause the application, and the application becomes unavailable, which is not great. You can tune the JVM to do things a bit better, but by default, out of the box, your application is going to become much less responsive. And that's one of the main reasons the latency is going to start being different between WebFlux and MVC, because the use of the memory is slightly different from non-blocking and MVC blocking scenarios. The other thing is, the latency might be different. We're still talking about a hello world. So in theory, what we expected when we had this test is not a huge difference, but we see already a difference, which is great. Just because we worked also on optimizing very simple scenarios, and a lot of new frameworks do that. MVC is also not the latest framework around, so we haven't refactored everything. We keep it because we believe in choice in the Spring team. We want you to have the choice between MVC and WebFlux. And we don't want to do a full transition, like all into WebFlux. We're not like a 100% reactive framework nowadays. We just want to give you the choice. So yeah, there might be a difference, but that's not the most important one for now to think about. Just remember that there is a memory difference for now between the WebFlux and MVC scenario. Maybe an extra hint. Do you know why one application is using more old gen and the other one is using more young generation? Well, that's because in the WebFlux case, we actually don't keep the same object references in the same place for too long. That means we can actually clean up more quickly, and they are not promoted into old generation. And in the MVC case, when the request, when they are waiting for a thread to be available, they stay in this request queue, and they stay there for quite relatively a long time, and they are candidate to be promoted in the old generation. That's the main difference. In asynchronous, in WebFlux, we will move this reference all around, sometimes transform it into another reference. In MVC, we will keep the same reference, the same request will wait for relatively a long time in the same queue in front of the Tomcat thread pool. That was it. Spring Boot gives you the choice. You can use a starter for WebFlux or for WebMVC. Right.
And with the fact that we support the reactive types, you need only to change the starter in your POM XML and your application will work with the WebFlux, for example.
If tomorrow you can make it in time for the keynote, we'll try to do a small demonstration. Because I think the key takeaway we want to give for you to keep is that we try to keep a consistent programming model between WebMVC or the classic way you already know Spring, because a lot of people have invested a lot of time in learning Spring, and we don't want to lose the community by transitioning to reactive programming. So you will see a lot of conventions working in both in reactive and non-reactive environment. But you will see that hopefully in the demo tomorrow if it works.
It will work.
It will work.
Also with...
Can we have the buff scenario in the same, the buff style in the same?
That's correct.
Yeah.
With 5.2, you are able now to use functional programming model also with WebMVC. So you will be able to compare both annotation-based processing model in MVC and WebFlux, and then functional-based also.
So, and just to repeat again the question was, can we actually have run the same, in the same container, like the same Tomcat instance?
Same server, yeah.
Yeah, same server, reactive and non-reactive stuff.
That's correct.
So the short answer is no. The long answer is you can start using reactive stuff with Tomcat, but once you switch to NEDI, so WebFlux, you cannot use anymore the non-reactive stuff. And you cannot run two different servers because they will have to use two different ports. Like you cannot run NEDI and run Tomcat. One will be like on port 8080 and the other will be on whatever port available. They will be in conflict. So on WebFlux, you can only do reactive. And on MVC, you can do a mix between non-reactive and reactive. But it's not going to be as efficient as WebFlux because it will still run on top of a servlet container like Tomcat or JD. So you can, but it's not the full flavor of reactive, which is WebFlux.
And you should know that actually the servlet API is not available with WebFlux, so you use only the Reactive Streams API.
Right. Let's continue. And for the next question, we'll see if we can answer them or if we have time at the end.
Okay, now in the second scenario, we want to simulate somehow a slow client. So we'll put a delay on our response on the server in order to see how our application will behave. And also, I have one additional scenario here where I increase the threads in the server's thread pool in order to see whether with more threads I will have better or worse results. Again, this is the WebMVC controller. This time I use asynchronous. As you can see, I'm using also the reactive types. And when I return the response, I delay this response with 100 milliseconds. This is the same for WebFlux. And when we want functional, here we need more coding about that. But again, at the end, you are delaying the response. What we see as a first thing, we have an increase in the used memory, and also we have an increase in the old generation. And that's because when we are using delays in the WebMVC and asynchronous processing, we actually have additional thread pool where we can do this additional processing.
And look at the top right graph corresponding to the use of all generation space. You can see the time spent in garbage collection is quite larger, compared to without the delay. So it's degrading quite a bit.
And actually what we have is, we do not speak now for requests number because when we do not have a delay, it's normal that we will serve more requests. But what we see as a response time, that this time we have 4 times slower response than in comparison with when we do not have response delay.
And please don't be these people who actually benchmark application using average latency. Do not do that, please. Use tail latency. That's more important. Thank you.
What happens if we increase the thread pool to 600 threads? Not a big difference in the resource consumption and also in the requests that are served and the response times. We do not see a big difference. So even with more threads, we are not able to serve more requests. What we have with WebFlux. Here is the comparison with WebFlux with and without response delay. From resource consumption, we do not have a big difference. What we can say for the response time, the fact that we delayed the response actually does not affect the response time when we are in a WebFlux scenario. Now, next scenario, streaming. Till now, we are sending one very, very tiny message, hello world. Now, let's send something bigger. What we have as a controller, we will send as a stream 50 elements, and every element will be 1K bytes. This is the WebMVC. Again, it is asynchronous, uses reactive types. And the same is for WebFlux. And for WebFlux FN, we have this controller. So from the resource consumption, we cannot say much about what happens with the requests. But if we look at the requests that we are able to serve, actually with WebFlux, we are able to serve a lot more requests. And if you take a look at the response times, you will see that we are 2 times slower with WebMVC. And what will happen if we try to delay the response with streaming? This time, we delay elements with 100 milliseconds. This is WebMVC, the same is WebFlux, and this is the functional controller. Our memory increased, and what happens here, again, the request number that we sent with WebFlux is more than what we can send with WebMVC, and the response time is again 2 times slower than before, than WebFlux. And now, the next scenario, I added another application so that I was able to do a remote call and measure this scenario. And in addition to what I had Spring Web MVC and WebFlux, I decided to create 2 applications for Spring Web MVC. The first one will utilize the blocking REST template for the remote call. And the second one will utilize the web client, which is non-blocking and reactive. So let's see what we have. This is the controller for the web MVC. The first one uses the REST template, the second one the web client. The WebFlux is the same as MVC when you are using web client. And this is the controller for WebFlux functional. From the resources, again, we cannot say much what happens with the requests. But if you look at the request numbers, you can see the difference here. And that's because we use the blocking REST template for our remote calls. Also, take a look at the response times. In MVC, they are really
yeah, the tail latency
not
is,
okay.
yeah, tail latency is actually 10 times slower.
And what happens if we switch our MVC application just to use web client for the remote calls? Here you see that the memory in comparison with the use case with REST template is increased, but actually what happens with the requests is that with web MVC, with web client, we are able to serve a lot more requests than with WebMVC with a REST client. And also, if you look at the response times, they are better with, in comparison with what we had with the REST template. And if we look at the three of them, you can see that if you just want to make your WebMVC application more responsive, just switch from the blocking REST template to non-blocking web client for your remote calls, and you will immediately see the difference.
That's something we really want you to make use of if you're really starting your journey into reactive programming. Don't go all in WebFlux. Start with Spring MVC, so don't migrate your Spring MVC application. And instead of using REST template, replace it with web client. And already you kind of get some benefits. So, and we see that here, but also in general, you can also learn more about reactive programming just using the web client. You know, you don't have to convert everything. Just using the web client, you learn with this new API how it works, and you get more comfortable with this API only. And when you're ready, then you can switch to, if you even need to switch, you can switch to WebFlux. And you're ready already because you started converting bit by bit your blocking code into non-blocking code.
And the last scenario is a remote call with a delay. This time we want to test the scenario where we have 100 milliseconds processing latency on the remote system. The controller is the same as previous because this time we just call a system where we know there is a delay on the response. And yeah, what we see is almost the same situation as the scenario without delay. With REST template, we are not able to serve as many as with WebFlux, and yeah, the response times are really not okay. With web client, again, increasing the memory usage in the old generation. But in comparison with what we have with REST template, again, web client is better when you use it for your remote calls.
Mm-hmm.
Right?
Yeah.
But it's still the external server, maybe database, or it's like a REST API. They will take some time. For example, they are taking 5 milliseconds.
Mm-hmm.
So that time has to be added to the response, even in case of the client.
Yeah, but these measurements are made on the server that makes the remote call. So you want your server to be responsive. So, okay, the remote system will have some latency, but with non-blocking web client, you will be able to serve more requests that are coming, because you will not block the threads.
Yes, in a more server, if you're using non-blocking web client, if you want to make that more web service call, then we can pick on the same thread. We can use the same thread for other service to call. Then it makes sense.
I'm not sure I got the question, but if I may, I think you're saying that does it make sense to even if we have one remote service we're calling to use web client instead of REST template, for instance? Oh, Amber Alert. Yeah, it makes. I think it makes sense because the important thing is your incoming traffic. If you're still in like API gateway or mobile backend or whatever, and you accept like thousands of requests, you can you can have some benefit in using a web client because you will be less or more efficient than the REST template. So at least the processing side will be less impacted by the remote system. Web client makes the remote system less impacting for yourself, basically.
Is it like back pressure that we have?
On the web client side, yeah. On the outbound call, yeah, there will be back pressure happening.
That's only benefit.
Yeah. What? Sorry?
So that's only benefit in case of if you're calling only one API call.
Yeah. Also, one or n or many. You already have at the first request. You already have a benefit from doing that.
Because you do not.
Well, we'll see that in the benchmark actually. We only call one service in the end. For each request, we call one extra remote endpoint, and yeah, it's already showing some benefits. If you have more questions, don't hesitate at the end. Let's just again, I don't want us to be in between you and lunch. So let's wrap up on the last thing I would advocate for when we talk about reactive programming. Something that is really important, again, reactive programming makes your application more resilient. So let's see why and how. The thing is, why we want application to be more resilient is because we don't want to pay too much for having people on call ready to restart the application when there is a problem. With reactive programming, what we have already seen is we have a better prediction of memory consumption and resources used because it will use less resources. So that's interesting. But also, we'll see an interesting aspect of NEDI. When there is an error, the error tends to be isolated to a given connection. So when a connection has a problem, we treat the connection directly, so the one user which has the problem. With a servlet container, it's not as evident, and we'll see that in a second. The other thing is, under stress, and we've seen that in the benchmark, the application is more available because it spends less time in garbage collection. So if you have a huge peak load, it's Christmas and you are retail and you have all this interesting shopper coming to your site and you're a successful business, maybe there is an N+1 user who's going to submit his form, his shopping cart, and when he's doing that, actually, an exceptional exception, very something you don't see very often, will happen, unfortunately, because it's uploading. For instance, the request is uploading a body, post form, for instance, and this is the extra one you shouldn't have accepted, and it's too late. The application is failing at this point. And what happens is when you have an out-of-memory exception in Java, I guess you know the answer. You actually are good to restart the application. And then, not only you, but also all the other shoppers waiting in line or submitting the form are experiencing a very graceful shutdown. After 45 seconds, probably, or 50 seconds, they will be notified that what they've done is nothing and they can restart. And they will be probably super happy. And maybe they will switch to competition, and no one wants to be in that situation. And at this stage, you have probably a boss calling you or OPS and asking them to do something quick. Or you have application platform that does that for you, but the problem remains the same. The application is failed, there will be a lot of people pissed off, and you have to restart at some point. So when we deal with reactive programming, at least what we're doing with NEDI, we try to isolate these issues. So when we read the extra, because we can be out of capacity as well, we don't have an infinite capacity just because we're doing reactive programming. At some point, we will be out of capacity as well, even if the threshold is much higher. When we are out of capacity, we will receive an exception from NEDI. And this exception is actually not an out-of-memory exception. For us, it's called direct memory exception or something like that. But it's not an exception that will fail the entire application. That's a runtime exception. It's not a fatal error for the JVM. That's the important thing. So what happens is NEDI will catch this exception, close the related connection, or you can also provide a fallback answer. Projects like Spring Cloud Gateway will do that, for instance. And then the client will probably retry. He still has lost his request because it didn't work. Maybe he will retry, it will still not work, but only this client will be affected. And the other client, still connected, still submitting the shopping cart and shopping on the site. So nothing really happened. Well, obviously there will be a debrief on Monday, like the server has been out of capacity at some point, so maybe we'll need to project more resources for the future. But at least the application didn't fail and bailed on you. And that's, I think, on par, if not more important than the performance aspect of reactive programming. The fact that you can make application more resilient is really something that says something at least to decision maker choosing architectures and stuff. So to finish, if we look again at the priorities, please stop annoying me about that. If you look again at your priorities, maybe we're not in the business to make application faster than the competition when we create reactive application, but actually we are in the business of doing state-of-the-art application, at least in an efficient way. So we try to make you efficient at creating this kind of application that scale, that are resilient. Obviously, it takes a bit of time to learn about this stuff. And again, we don't want you to do an all-in on these things. But you cannot say that it's making you not productive. It just makes you more productive at creating better application that can scale under these conditions. And that's important as well. About the other priority I explained about day 2 operation and observability, you are making applications that are resilient, so under stress, they are kind of self-managed. You don't have to have someone really on call in case there is an exception happening, ready to restart the application. So they are lower maintenance. And that's kind of something as well, that when you discuss the qualities of reactive programming. And we've seen that already, we consume less resources, especially in use cases where applications are under stress, with delay, with call to a remote backend, or with a mobile client. All of these use cases make a good point for good argument for reactive. And you will run more applications for less because you consume less resources, so you can do more, with the resources you have paid for already. It's not something necessarily people like Amazon will like to hear about because they make less money, but it's, at least I don't see it this way. I think it's important to scale less of the same application, clone the same application instance to make sure it scales with the traffic, and do more microservices, more different microservices. That's the point, of microservice architecture. You want to have a really contextual, delimited microservice architecture where each microservice is a different function of your business. You don't want to have less microservices because you are constrained by your resources. That would be annoying. So we enable people to do more microservices in general, but in reality, we allow people to pay less per bill, actually. And that's a cool thing, especially in these times of uncertainty. The market is going to turn around and we're going to be in recession. Cost is going to be an important thing again. From this perspective, I think we should look at it as well. So we have 7 minutes to answer some question, and I'm super happy. That means we won't be in between you and the lunch. So do we have question now? Yep.
I was curious if there were any benchmarks against like a node application that uses the event loop, much like the same way that WebFlux does. Is there an increase in performance for us to use WebFlux, or is it like about the same?
So the question is there a difference between WebFlux and Node.js, for instance? Yeah. So Node.js uses one thread. A Java application can use multi-threading. So that's kind of a difference. We can make kind of efficient application on the JVM. They scale differently because you can run multiple Node.js application as well. But we haven't directly benchmarked against Node.js. And the theory says that it should be more efficient because in the same application you have more thread. So yeah, especially when you are CPU bound, you can treat more connections, with multiple thread. So again, it's just because the JVM has multi-threading support that it can be efficient. And we're not the only one doing that. Like if you look at other frameworks, aka HTTP or Vertex, They do the same, and they use the power of the multi-threading to scale better inside one application. It will use more memory though than Node.js, but that's the cost of multi-threading as well. So yeah, no direct benchmark, but the theory says it should scale, it should perform better. But please, if you benchmark it, let us know. Any other question? Yep.
So if you have a non-reactive backend, your database, a relational database which is non-reactive, would it make sense to go reactive?
Right, so the question is, if we have a non-reactive database, especially a relational database, because most of the non-relational database have an asynchronous driver, does it make sense to do reactive programming? And the question is no. The answer, sorry, is no. And that's why one of the main reasons we keep Spring MVC as well as an option, because we don't want you to, if you cannot migrate everything in your non-blocking application, you cannot, in a blocking application to non-blocking, you cannot make use of WebFlux. And that happens quite often, actually. You'll see in the keynote tomorrow, we have statistics about how many users use relational database. It's basically the majority of users. So that's a big problem, and the answer will be use a microservice for the blocking use case, like accessing this database, this blocking database, or this blocking driver directly, and use another microservice which will compose the result with WebFlux, for instance. That's the beauty of microservices. You can have a blocking that will scale differently, and you can have a non-blocking one that will be cheaper to scale in a different application. Any other question? Yep.
And I don't know if this gets covered maybe in some of the other sessions, but how does like our socket tie into the reactive stack, where it's supposed to kind of have some of these reactive features baked into the network layers?
So the question is, how does RSocket relate to the reactive stack we have now in WebFlux? It's a good question. We'll cover that tomorrow, and right now Rosen is talking about it in his session. So all of these sessions are on YouTube. So replay them as soon as they are available online. The short answer to that question is it is an extension. So right now, what we're doing with reactive programming is only inside the application, and that's cool because we make more efficient application. But if actually you could compose different application in a reactive way, you will have an end-to-end story, and you will have the benefit of all the stuff we do inside the application, but for multiple applications. And that's why what we call a reactive system, basically. Reactive programming is only enabling one application to be better, sort of. A reactive system is a whole, a set of application. And with RSocket, you can communicate these qualities between applications. So the main difference is you will be much more efficient using RSocket with reactive application versus using reactive application and HTTP only, for instance. That's the main major difference. And we get into some of the details in other sessions, not in a keynote, unfortunately, because keynote are usually not the place where you learn new stuff. But in the sessions, you will learn more about the differences. And it's something we really believe in. I advise to have a look at RSocket as well. Yep, another question.
Completable feature versus WebFlux, doing comparison and
But what about completable feature?
completable feature, you can do parallel calls, right? So you can do parallel calls and then add response back, right? So you can.
So the question, just repeating the question is how does it compare to a completable feature, which you can use with adapters, I think, in Spring MVC?
As I said, in Spring MVC, you are still blocking. So even when you have this architecture, you should return again to the server thread and write the response. And once you start writing the response, the server thread will block. right?
Yeah, the thread will be blocked, but the remote calls that I'm making from the main thread, right? So they will be spread out. Whatever the maximum number a remote call is taking, that is the maximum number of my response time in that case, right?
Yeah, but for splitting these remote calls, you still use some thread pool, right?
Yeah.
And if the remote system is not responsive or it's a slow one, again, you will be in the same situation as I showed. At some point, you feel this thread pool and again...
That's exactly the situation in here. Like if your web client will be, for instance, equivalent maybe close to asynchronous REST template and maybe returning a completable future. But you will be more responsive than just REST template, but you won't be like nowhere close to Nady, because it's not because you add more thread pool that you actually resolve the problem of not sending traffic or receiving traffic. That's what we do in Reactive way. We can stop reading the traffic if we know in advance we won't have the capacity, so we don't overload the resources. That's a major difference between what we do with Nady and reactive streams. And that's also what we call back pressure, avoiding traffic if we cannot accept it. Any other question? Okay. Hold on a second, because you had your questions first. Yes?
Are you aware of any efforts to create like a reactive SLF4J library?
So is there any effort to create a reactive library for SLF4J, or I guess in general logging? I guess the follow-up question will be, is there a way to have the metadata context or something like that to have the logging correlation? No. Short answer is no. Yeah. Long answer is maybe use log4j too, because at least you have an asynchronous appender. It's something I remember from my consulting times. We underestimate the impact of logging on application, especially on a critical path. Sometimes it's actually huge. When we have to diagnose this application, one of the first things we advised at the time when I was consultant was to try switching from a normal appender to an async appender. And that usually has some great benefit, but there is not yet, as far as I know, reactive log4j, unfortunately. However, it's on our radar to see how we can improve the experience of using log4j or any logging framework with reactive stuff. Sorry, it's not really the best one.
It was our biggest pain point when we started using WebFlux.
Yeah.
Like we probably sunk more dev hours into solving the MVC into the reactor context problem than anything else for WebFlux.
Yeah. And actually, we try to collect the maximum feedback. So if you have time later about that, because this specific issue is a tough one and we don't have a single answer to this one.
Actually,
Yeah.
if you attend next talk, then you may hear something about it.
Yeah, go to the Sergey.
But yeah, I'll be talking about it.
Sergey, in his next talk, I think in this room, is going after the lunch, obviously, we'll be talking about some of this stuff as well. So maybe that will be interesting to be there. Another one, so I think we only have time for 2 more questions. So I'll take, if you don't mind, I'll take yours after. I'll take yours now.
So you mentioned debugging is Stephane.
Yeah.
And I agree. Are there things to do to make it easier to debug when things are going wrong?
Is there any way to make the debugging pain easier? There are. I would redirect you to Sergey's session in 2 hours after lunch. Especially after lunch, we will be so filled and ready to accept this answer. Okay, I think we're good. Let's take the rest of the question offline if you don't mind, and thank you for staying that late. Cheers.